Hi everyone, my name is Thomas Kim. Today is April 28, 2019. This is my first episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn C++ 2A standard called parallel algorithm. Using this algorithm, we will learn how to sort in parallel. Through this series of videos, I will cover the following list of things. First, we will learn threading in C++11 standard. Then we will cover parallel algorithm in C++ 2A standard. Then we will learn coroutine in C++ 2A standard. We will learn concept in C++ 2A standard. In future sessions, I will add more items in this list. To follow this session, please visit this website. From this website, please double-click this link to download source code. Then please watch this video about setting system environment variables. If you want to follow this series of videos, you probably have to watch this video and have to properly set environment variables for our development. Please note that April 28 is today, and I implemented this chrono random namespace, and I haven't tested them thoroughly. I just created them today, just a couple of hours ago, and uploaded to the FTP site, so it can have bugs. I will fix the library anytime, and I will add more algorithms and more namespace. These are namespace and more functions and more features. In case of set, I already implemented lots of core algorithms used in set operation. These can be quite useful for advanced C++ programming or advanced algorithms. And I will update all these libraries and documentations, and I will convert into parallel algorithm according to future C++ standard. Okay, let's get started. Start your File Explorer. Then in D drive, dbsoft, cpp extension root, cpp extension. If you unzip the downloaded file, this file, then you can find cpp extension. In this folder, we will create tutorial folder. Tutorial. Then you can click like this, double click. Then right click your command prompt. Right click, properties, paste the folder, apply, OK. Then start Visual Studio Code. Go to File, open folder, paste the folder path, select folder. In this folder, new file 001, parallel, sort, cpp. Click enter, Ctrl V. Here include talk, play, fun, chrono, random, HPP, like this. Then include once again talk, play, fun, output, HPP, void examples for random stopwatch. Create a function like this. Then int main, copy this function name like this. If you see this kind of squiggle, then you probably have to make some settings. Ctrl Shift P, edit, C++ configuration, JSON, probably this one. Then here, quote, $, CPP, extension, dir, you can put like this, and you have to delete. You have to fix like this. Then you can save all. Then you can close it. Here at global scope, we will create a few stream functions. Talk, play, fun, SS stream, stream. Just create an instance of stream, auto, NL. We can simply create like this. This is one new line, auto, NL. We can create two lines like this. Two carriage return, auto, then flush. In this case, you have to have talk, play, fun, output, NL. Okay? You have to create a few stream class like this. Now here, stream, hello, parallel, algorithm. You can say flush like this. Now let's compile it. Let's see, Ctrl Shift P once again. It should work. Okay, now let's ignore it. Okay, it's gone. Start your command prompt, dir, then you can see 001 parallel sort CPP. We will try with Clang compiler first, Clang++. Don't forget giving std, C++2a, 001, parallel sort CPP. Okay, hit enter. Now you should see this message. Then let's try with GNU compiler. I give the same command message. Okay, it works. Now with Microsoft compiler, CL, EHSC, std, C++ latest, we will give MD switch for dynamic DLL library, then 001 parallel sort CPP FE AEXE. It should also work like this. Now let's learn about random and stopwatch. Step 1. Define namespace, alias, and some types we will be using. Namespace, CRD means chrono random, like this, talk, play, fun, chrono random. We define the namespace alias using element t. It can be double or int. We will define double. We defined an element type. Then using container t, we define std vector. We provide element t. Okay, this is vector of type double. Step 2. Create a random number generator like this. Auto generator. We can just use generator like this. CRD. CRD is the namespace we defined here. Random generator. Okay. We have to provide element type. This is element type. Means we are going to generate type double. Okay. Then we give range from 1 to 100. It means we create a random number generator that generates type element T or double. In this case, the range of generated doubles are from 1 to 100. Okay, this is generated type, this is range, lower bound, this is upper bound. We generated a random generator, then we define container. Container T, we define the container T is type vector. We just define V like this. Okay, now here we compare the random numbers like this. CRD, this is the namespace, chrono random namespace, random fill. Okay, then here we provide V like this. Then generator, we have to provide generator. This is how many elements we want to create. For example, 20 elements of vector. Okay, here step 3, create an object of type container T, in this case SED vector double. Okay, then step 4, fill the container with random numbers using the random number generator created as step. We created random number generator as step 2. Here this number 20 means we generate 20 elements of type element T or double. Okay, now we display the number like this. Stream random numbers, we can display like this. V, this is the container. Then NL, if you don't flush, then you cannot see your result. This is string stream. This is based on string stream, so you have to flush like this. Stream V size random numbers are generated. Then you have to flush. Okay, if you don't use flush command here, if you don't end stream with flush here, you cannot see your result. The reason is for optimization. Okay, now we can build and run and examine this code like this. This is Microsoft compiler. Okay, you can see like this. Random numbers. This is double from 1 to 100. 20 doubles. Okay, you can see 20 doubles. 20 random numbers are generated like this. Let's try with GNU compiler. GNU compiler also works. Now with Clang, this is Clang. Clang also works. If you don't like double, this is these are doubles, then you can change it here, just int. Okay, just changing this int, everything would be changed into int. Okay, so we try with Clang again. Now we are generating integers, random numbers of integers from 1 to 100. Okay, also you can change the range here. This is generated number, not count. We will make it shorter, 10 integers, 10 elements of type element T. Okay, Now we shrink the range, for example 20. Okay, it means from 1 to 20 inclusive. Okay, now we build, this time we will compile with GNU G++ compiler. Now you can see the configuration. Okay, 10 random numbers are generated. I hope you understand how to use this. Now I copy this function. We now use serial sort. Okay, I copied, pasted like this here. Example for serial sort. Okay, I modified the function name. I will change it into double. Okay, then I will make it bigger number from 1 to 100. This is range from 1 to 100. This is the magnitude of generated number. This is not count. Now we are creating here another step. Size T. Size. We want to generate 1 million doubles like this. This is 1 million doubles. Okay, so from here, from 1 million doubles, we give size. We are generating 1 million double. Okay, we fill this. Then we cannot display like this. It's too big. So we delete. Too big. Okay. Then I will also delete this part. Now I will define another one. Size T. Test count. I will define 5. We are going to test 5 times like this. For size T, I equals 0, I less than, test count, then plus I. Here, auto sorted container. We can copy B because it is initialized here, B, like this. Then we sort. Before we sort, we will create a timer here. Timer, CRD, stopwatch. Okay, SW. We can create a stopwatch like this. Now we begin to start SW, reset. We have to reset the time. Now we sort. SCD, sort, sorted container, begin, sorted container, end. We sort. Okay, then we can display like this. Now I will create a function here. Template, type name, container type, void print container, size T, index, constant, container type, container. Then here, constant talk play fun, chrono random, stopwatch, SW. Okay. Or if you don't like to type this long name, if you don't like to type this, then you can do like this. Type name, stop, watch, type. You can just copy like this. Okay, if you don't like to type like this. Then here, stream, we first display index, then colon, minimum, I will do like this, minimum elements of this container. So container front here, maximum container back. Then we can say elapsed. We can provide like this. Stopwatch. This is stopwatch. Elapsed time. Then, and we have to flush. Okay? We don't need to flush. NL like this. Or we can just say one carriage return. We created this function, then we are calling this function like this. Here, print. What's this function name? Print container. Copy. Paste. We pass index I. Then container sorted container. Then we need to pass the stopwatch SW like this. Okay. This stopwatch resets itself, so we don't need to concern about this. We are measuring only sorting time, sort time. We defined like this. Now we copy this function for serial sort. We paste it here and we disable it. Now we build here. We are using GNU compiler. Please note that we are sorting million elements. Container here. It comes from here. Container type and stopwatch type. What's the error message? Container. I made a type here. Then let's compile once again. So it's working. Why it's not displaying anything? So don't forget this. Don't forget. We have to flush. Okay. After doing this, we have to flush. Stream. We have to flush. If you don't flush, then you cannot see anything. If you don't flush, you cannot see anything. Okay, now let's build once again. It's sorting. So minimum value is 100, maximum value is 999, and the elapsed time is displayed like this. Okay, I will make one more changes here. At this point, stream serial sort NL. I modified like this, and in command prompt, now let's compile with Microsoft compiler like this. CL EHSC SCD colon C++ latest. We probably have to give MD switch 001 parallel sort EL. Then .cpp fe Microsoft unoptimized exe. MU means Microsoft unoptimized. Hit enter. MU this is Microsoft optimized case. The result is displayed like this. Now we give optimization switch here O2, okay, and we change the file name MO, Microsoft optimized. Hit enter. CLS MU, this is an optimized case. MO, this is optimized case. Please compare the time, okay? In case of unoptimized, it ranges 590 something, okay? If we give optimization switch O2, it ranges 106 milliseconds. It's almost four or 5 times, okay? So giving O2 option, C++ compiler, optimization compiler, gives us 4 or 5 times faster result. Now let's try with Clang compiler. Here, Clang, we give an optimization O0. This is an optimization. Then here, output O, Clang unoptimized exe. We are building using Clang compiler an optimization switch. Now we give Clang optimized CO and give option O3. Hit enter. Now CLS CU, this is an optimized case. CO, this is optimized case. Wow! Microsoft compiler compared with Clang, this is Clang compiler, and this is Microsoft compiler. Clang compiler is faster. This is Clang optimized. This is Microsoft optimized. Clang compiler wins in this case. Now let's try with GNU compiler. G optimized. We are compiling GNU compiler optimized. GNU compiler unoptimized. Okay. Then it should be O0. Hit enter. CLS. The first is Clang, C optimized, Clang optimized. Second is GNU optimized. Third is Microsoft optimized. Clang is most fast. Then comes GNU compiler. Microsoft compiler is slowest. Now let's go parallel. Take a deep breath, then we go parallel. Here, copy this file, right click, copy, then paste. Here, right click, rename, 1, then here, MSVC. Currently only MSVC is supported. So I will close this. I will copy from here. I copied and paste. I will rename parallel sort. Then I copy this function name, copy, paste it here, and I will change the message here, parallel sort. sort. Then we have to include here, we have to include execution. Okay, we have to include this. As of today, April 28, 2019, only Microsoft Visual C++ 15.7 version implements C++ 2a parallel algorithm, possibly latest version of Intel C++ compiler 2, GNU G++ version 9.0, Clang version 9.0 will be released very soon. Then we can try this program too. So here I scroll down in parallel sort. Here I will give only one switch, SED, execution, parallel, unseq. So I added only this option. About this skill, just ignore it. Okay. Now we build using Microsoft compiler. Here it should be MSVC. Hit enter. Okay. CLS-MO. Wow. Parallel sort is 66 milliseconds. Now let's try Microsoft compiler, GNU compiler, serial sort, Clang compiler, serial sort. In case of GNU and Clang, parallel algorithm is not yet implemented according to C++ 2a standard. In case of Microsoft implements parallel algorithm, this gives 61 millisecond. It's most fast. Note that I use MSI CR720 Intel Core i3 370 8 GB memory, 500 GB SSD. It supports 2 cores and 4 threads. I am also filming this video. So in your case, this result can be much faster. You can download complete source code by clicking download link in the description section below. In future sessions, we will learn about threading in C++ 11 standard and 14, 17, etc. And we will learn more about parallel algorithms in C++ 2a standard. And we will also learn about Coroutine. This is really powerful. And we will also learn concept. C++ 2a standard is very much different from C++ 17. Please subscribe to my YouTube channel. Thank you for watching.